Okay, so here now we're multiplying, and out of add, subtract, multiply, and dividing with fractions, multiplying is the easiest because you don't have to worry about as many things. So let's see what we got. So I could go straight to saying 2b times 15c is 30bc, and 3c times 6bc is 18bc squared. I could do that and then cancel stuff and say, well, 6 goes in 3 times and 6 goes in 5 times. And I can cancel the b's and I can cancel one of the c's, and then I'm done. Or an alternative method would be to say, hey, if it's multiplication, it has to be multiplied. Can't be add, subtract, or divide. If it's multiplication, I can cancel anything on the top with anything on the bottom. Well, any factor on the top with any factor on the bottom. So I could say, hey, I will cancel a 2 right there and right there. And I'll cancel a 3. Well, actually, I'm just going to use this one. I'll cancel a 3 right there and right there. And let me change colors. And I'll get rid of the B's, and I'll get rid of a C. And then what am I left with? Well, right there, nothing. Right here, just the 5. Right here, just the 3. And right here, just that C. And I get the same answer. Well, it doesn't matter which way you do it, but a lot of times this method in red is preferable because the numbers don't get as large. Now in this problem, they didn't get that big. 30 and 18 are not that big to worry about what you can cancel, but sometimes they do get pretty big. And so a lot of times it's nice to do canceling first when possible. Okay, so now we're doing the same thing, except there's a little more going on. We got to factor first. Well, that's fun. I mean, ask anybody, they'll tell you. So the first denominator is linear, no GCF, so it doesn't factor. Okay, so that guy's good the way he is. All right, I like starting with the toughest or the easiest ones first. Let's build up my confidence. All right, the second numerator, same thing. It's linear, no GCF. The second denominator has a GCF of 3. And that's as far as that'll go. And the first numerator, we're going to need to do AC method, but it's A equals 1, so I can shortcut it. And I'm going to get that. And now once it's factored, you've done pretty much all the work. Now you just hack and slash and just cancel whatever can be canceled. And we're left with an x plus 1, and x minus 3 on top, and that 3 and x plus 2 on the bottom. And that's it. Once again, I exhort you to plug in the original for y1, your final for y2 on the calculator, see if they match on the table. Now on this one, there's not much difference. It's division in the middle. That's the main thing there. And when you divide by a fraction, like you say, hey, 3/5 divided by 2/7, we learned a long time ago that this is the same as 3/5 times the reciprocal of the second fraction. It gets flipped. Then it's a multiplication problem. And then it's just like what we've been doing. But a word of caution, I cannot do any canceling at this point from one fraction to another. Okay, from one fraction to another. I can't do it because it's division. It has to be multiplication. Okay, so this is going to be x minus 1 over x squared plus x minus 6 times, and again, I'm not going to use the x for multiplication because I'm already using it for a variable. To get the reciprocal of the second fraction, and now it's exactly like what we were doing a second ago. Big deal. All right, so let's factor everything because you can only cancel factors. That's why we do it. And it looks like plus 3 and minus 2 will multiply to -6 and add up to +1. And Then we can pull out a GCF of 4. Okay. And then we can cancel and x minus 2. And that's it. Usually they'll let you cancel more, but whatever. So that'll be x minus 1. Oh, I should put the 4 out front. It doesn't matter, but it's tradition. And then x plus 3, x plus 2. And there are no common factors between the top and the bottom, so we know we're done. Okay, same thing again. Get rid of the division and then factor everything so you can cancel. Okay, so we're going to have 5x squared minus 3x minus 14. 3x squared plus x minus 2. And we're going to multiply that by 3x minus 1 over 4x minus 8. All right. So we go ahead and we start factoring stuff. Okay. So that first numerator, let's see, it's going to be like that. And in the interest of time, since we've already learned it, I'm just going to write down the factored form. And I get that. And then the first denominator is going to be 3x and x. Okay. And then a 2 and a 1. I think, wait, nope, hang on. And we get that. Now the second numerator is linear with no GCF, so it doesn't factor. And the second denominator, we can factor out a 4. Now, we've done pretty much all the work. Time to cancel what we can and plant our flag and declare victory. And that's it. Now, some people think that these look a little bit more intimidating. I disagree, because there is no addition or subtraction, which means we don't need to worry about any high-powered factoring. Okay. First of all, we got a fraction divided by a fraction. Well, we just talked about how to handle that. That's going to be 9n cubed over 7p to the 5th q cubed times, I guess I can do an x this time, the reciprocal of the second fraction, or the bottom fraction. Okay, now everything's basically factored already, so it's time to go straight to canceling. Cool. Well, I could get rid of 1q in the top and the bottom. I could get rid of 3 p's in the top and the bottom. I could get rid of a pair of n's in the top and the bottom. I could cancel, let me change my colors here. I could cancel a 3 in the top and bottom. I could cancel a 7 in the top and bottom. Or I could multiply everything out first and then do the canceling, but I don't want to. And that's, I mean, this is an amateur hour. Okay, so what's left over? Well, we got a 3 and a 4 multiplied together to give us 12. We still have a single n. And that's it for the top. In the bottom, we've got a couple of p's. And we've got a couple of q's. And we've got an m. And that problem is done. That's all you do. So yeah, there's no AC method or any of that stuff.